Alright, so let's look at some inverse trig functions. So the three we'll look at today is arc sine, arc cosine, and arc tan. Basically, arc sine is just the inverse function of sine. So let's say if you have arc sine of x, what that's basically saying is sine A equals x. And then same thing with these other two. Arc cosine x is cosine A equals x. And then arc tan x, tan A equals x. And also, something interesting about the inverse functions is that they have a restricted domain. So the domain for sine is, it's only between negative pi over 2 and pi over 2. So only in these quadrants right here. And then with cosine, or with arc cosine, it's only on, or from 0 to pi. So arc cosine is only in these quadrants here. And then arc tan is the same as arc sine. It's only in these quadrants here. So if you get an answer that's not in these quadrants, the answer is actually not there, because the arc sine functions only are in these domains right here. Alright, so let's actually do some examples of these inverse trig functions. So let's evaluate arc cosine of 1. So again, arc cosine of 1, if we put that in the same format, this is the same thing as cosine x equals 1. And here we just replace x as 1 and a as x. So now what this means, cosine x equals 1, this should be more familiar. This is saying what is the value of x, or what's the angle that will make cosine equal to 1. And there's only one answer to that, which is just 0. So x is 0, and it can't be 2 pi or 360 degrees, because if you remember, arc cosine only exists in the domain 0 to pi, and that domain is not, or 360 is not in that domain, so that's why x equals 0 is our only answer. Okay, so number 2 we have arc sine of -1 equals what? So let's do the same thing. Sine of x equals -1. And on the unit circle, this is saying what angle of sine is equal to -1. And there's only one, which is at 270 degrees, but we can't say 270 degrees because arc sine only exists in this quadrant and this quadrant. And 270 degrees, you would have to go all the way around, and that means you're crossing through quadrant 2 and quadrant 3, but you can't do that. That's why we have to go straight from here and do some negative angles. So that's why this 270 degrees is the same thing as -90. But let's use radians, so that means negative pi over 2. So that's why negative pi over 2 is the only answer to this. That's why it's the only answer, even though 270 degrees is the same. Arc sine cannot have 270 degrees. Alright, number 3, we have arc tan of 1 equals what? So let's just write it this way. Tan x equals 1. And if you remember, arc tan is the same domain as arc sine, which is in quadrant 1 and quadrant 4. So we have to find an angle that makes tan equal to 1 in quadrant 1 and quadrant 4, or quadrant 4. And we know quadrant 4 can't be the answer because this is positive negative, so we can't get anything from that. So we have to get an angle from quadrant 1 because this is positive positive. And the angle that will make tan equal to 1 is pi over 4, because the coordinates is root 2 over 2, comma, root 2 over 2. And tan is the same as sine over cosine. And sine, which is the y value, divided by cosine, which is the x value, will be just root 2 over 2 divided by root 2 over 2. And that's going to equal 1. So that means x equals pi over 4. Even though there might be another answer over here, but we can't use that because arctan is only in these two domains. Okay, so this one is a little different. We have arc cosine of 2 over 3, but outside we have sine. So this whole thing is inside the sine function. So these type of problems we have to solve a little differently. First thing you have to do is you have to draw a right angle triangle and then make this theta. And now you have to fill in the side lengths. So you're given arc cosine. So pretend arc cosine is not a thing. Pretend this is just cosine 2 over 3. And cosine is adjacent over hypotenuse. So, and they've given that's 2 over 3. So the adjacent of theta is this right here, so 2, and the hypotenuse is 3. And now let's just find this missing angle. So x squared plus 2 squared equals 3 squared. So x squared equals 9 minus 4 is 5. So x equals root 5. So this is root 5. And now all we're saying, because this is inside the sine function, all we have to find is the sine of theta. So we're given all the angles and theta. So theta, sine of theta is opposite over hypotenuse. So root 5 over 3. So the answer is just root 5 over 3. Okay, so number 5 we have arc sine 4 over 5 inside the cosine function. So let's start off by drawing the triangle first again. Alright, and this is theta. So we're given that sine is 4 over 5. So sine is opposite over hypotenuse. So opposite is 4 and hypotenuse is 5. So let's find the missing side. So x squared plus 4 squared equals 5 squared. And x should be just 3. 25 minus 16, 9, square root is 3. Yeah. So this is 3. And now this is inside the cosine function. And cosine is adjacent over hypotenuse. So we just take the cosine of theta, which is 3 over 5. And that's the answer. Alright, so number 6, we have sine. Okay, whenever you see sine to the negative 1, that's the exact same as arc sine. So don't be scared if you see something like this. Just know this is the exact same as arc sine. Sometimes people like to write it differently. Sometimes they say arc sine or they write it like this, sine to negative 1. But it's the exact same thing. So this is sine to negative 1 of sine pi over 3. So let's just evaluate sine pi over 3, which is just actually pi over 3 as well. On the unit circle, pi over 3, the sine value of that is just pi over 3. So let's just rewrite this as arc sine. So arc sine, and we know this is pi over 3. And now we did this before. So now we can just replace this by saying sine x equals pi over 3. And now we have to find a value of we have to find an angle of sine that will make it equal to pi over 3. And funny enough, that angle is pi over 3. So this is a coincidence. It's not going to happen all the time. But yeah, so all we had to do was just find sine pi over 3, which is pi over 3, and arc sine of that is the same thing. So x equals pi over 3. Okay, so we have cosine of arctan 3 over 4. So since this time the inverse function is inside a function, we have to draw a triangle for this. So we have theta and 90-degree angle. Okay, so tan, so they're giving us tan 3 over 4. And tan is opposite over adjacent. And so 3 is opposite, so opposite of theta is over here, so 3. And adjacent is over here, so 4. So let's find the hypotenuse real quick. So 3 squared plus 4 squared equals x squared. So 9 plus 16 equals 25, and root of that is 5. So now, we have to just find the cosine of theta, because this whole thing is inside the cosine function. And the cosine is adjacent over hypotenuse, and adjacent over cosine of this theta is 4 over 5. So we know the answer is 4 over 5.